We now discuss the solution of a problem from the section Binomial Theorem and its applications. The problem is based on the binomial coefficients, and this problem appeared in JEE Main examination held on 25th July 2021 in the session 2. The problem is, let n belongs to n, where n is the set of natural numbers, and bracket x denote the greatest integer less than or equal to x. If the sum of n plus 1 terms, n choose 0, n c 0, 3 times n c 1, 5 times n c 2, 7 times n c 3, etc. is equal to 2 power 100 multiplied by 101. Then 2 into the greatest integer of n minus 1 by 2 is equal to 2 times bracket n minus 1 by 2 is equal to. Let's now discuss the solution of the problem. Before the discussion of the problem, let us learn two very important properties of binomial coefficients which we are using in this problem. Let n be a positive integer, denote n choose r or ncr by capital C suffix r. The property 1 is C0 plus C1 plus C2 plus etc. plus Cn, the sum of the binomial coefficients, is equal to 2 power n. That is, sigma r is equal to 0 to n, Cr is 2 power n. That is the first property, and it is a very important property. Property 2, C1 plus 2 times C2 plus 3 times C3 plus etc. plus n times Cn is equal to n times 2 power n minus 1. That is, sigma r is equal to 1 to n r times Cr. R times Cr is equal to n into 2 power n minus 1. Now, the proofs are very simple. We have from the binomial expansion 1 plus x whole power n, where n is a positive integer, is equal to sigma r is equal to 0 to n Cr multiplied by x power r. Let's call this as the question 1. Now, putting x is equal to 1 in this above equation, you will get 1 plus 1 to the power of n, that is 2 power n, is equal to sigma r is equal to 0 to n Cr into 1 power r, that is 1. That is, sigma r is equal to 0 to n Cr is equal to 2 power n. So, that is, sigma r is equal to 0 to n, Cr is equal to 2 power n, and that is the first property, and it is a very important property, and it says the sum of the binomial coefficients in the binomial expansion is equal to 2 power n. Now, take this equation 1, differentiate with respect to x on both sides, we get n times 1 plus x power n is equal to sigma r is equal to 0 to n Cr into the derivative of x power r with respect to x is r into x power r minus 1. So, that is what we got, and put x is equal to 1 in this. Then you will get n into 1 plus 1 to the power of n minus 1 is equal to sigma r is equal to 0 to n CR into r. That is r times CR. So, we get n into 1 plus 1 whole to the power of n minus 1 is sigma r is equal to 0 to n RCR. And when r is equal to 0, RCR is 0 times C0. This is 0. Therefore, the summation can be written as starting from r is equal to 1 to n. R is equal to 1 to n. RCR is equal to n into 2 power n minus 1. And this is the second property of the binomial coefficients. These two properties are very important, and very often we will be using these two results. So, let us now go into our problem. So, let S is equal to NC0 plus 3 times NC1 plus 5 times NC2 plus 7 times NC3 plus up to n plus 1 terms. Let us call this as this equation. And now we write for NC0, NC0, 3 plus 3 times NC1 is C1 plus 5C2 plus 7C3 plus etc. up to n plus 1 terms, where n choose R or NCR is capital CR. And now if this is the case, C0, you can start with 1 times C0, 3 times C1, and 1, 3, 5, 7, n plus 1th term will be 2n plus 1, C0, C1, C2, C3, n plus 1 times is Cn. So, 1 times C0 plus 3 times C1 plus 5 times C2 plus 7 times C3 is equal to, plus etc. plus 2n plus 1 into Cn. So, this can be written in a sigma notation. Sigma r is equal to 0 to n, 2r plus 1. When r is equal to 0, it is 1 times C0 which will be starting, and when r is equal to n, and you will get 2n plus 1 into Cn, and thus this is the summation written in the sigma notation is this. Now, separate them. 2 times sigma r is equal to 0 to n RCR plus sigma r is equal to 0 to n CR. And we know what is sigma r is equal to 0 to n CR. And yes, the second step we have written is r is equal to 0 to n, we have written r is equal to 1 to n for obvious reason. Why? It is when r is equal to 0, it becomes 0, and the fruitful terms will be occurring only from r is equal to 1 to n. Therefore, the above one can be written as 2 times sigma r is equal to 1 to n RCR plus sigma r is equal to 0 to n CR. And we know the results, and we have already proved, and that is the sigma r is equal to 0 to n CR is equal to 2 power n. This is 2 power n. And sigma r is equal to 1 to n RCR is n times 2 to the power of n minus 1. That is, this is the property 2. And now substitute these two results here. 2 into n times 2 to the power of n minus 1 plus 2 power n. And 2 into 2 power n minus 1 is 2 power n. And that will be n into 2 power n plus 2 power n. And 2 power n is common, n plus 1 times 2 power n. It is now given that this sum is 2 power 100 into 101. Given S is equal to 2 power 100 into 101. This implies n plus 1 2 power n is equal to 2 power 100 into 101. And equating the corresponding terms, you will get n is equal to 100. Now we want to find the 2 times the greatest integer of n minus 1 by 2. That is 2 times the greatest integer of 100 minus 1 by 2. That is 2 times bracket n 99 by 2. 99 by 2 is 49.2, and the greatest integer not exceeding 49.5 is not 2, 49.5. the greatest integer not exceeding 99 by 2, that is 49.5, is 49. Therefore, 2 times 49, that is equal to 98. So that is your answer. So that's the discussion of the problem from the section Binomial Theorem and its applications, and the problem is on the binomial coefficients. I hope that you have understood the solution of this problem. I wish you all the best. Thank you.